Okay, what we're covering today is chapter 15, which is looking at random variables and kind of total events that happen. Oops, sorry. And so first of all, we need to understand what a random variable is. And a random variable, what it does is it's variables that assume different values as a result of a random event. Squeeze in there. And so we'll do some examples and that will start to make more sense. But what this is you have to make sure that you use a capital X. It's a capital, and that is because it's the overall results. So we're looking at the overall results. And it's really kind of looking at, we're going to find out what we can expect to happen. When you have one specific value, that's a lowercase x. But the whole thing, the whole event is a capital X. And so that'll matter sometimes when you're reading problems if you're not sure why it's in lower, why it's in upper. Upper is the whole thing. Lower is just one piece of it. Okay? So there's two different types of random events that can happen. You can have a discrete. And for a discrete random variable, it's a random variable that can take one of a finite number of distinct outcomes. Is that a small line? Can't fit anything in there today. And so this is counts. And so it's discrete. It has a finite answer. It has an exact answer. So flipping a coin is an example, because you either can get heads or tails. Rolling a die. So in that banana game, who's going to win the last banana game? Roll a die. Discrete are going to have no decimals. Okay. All right, and then a continuous. For a continuous, it's a random variable that can take any numerical value. Within a range of values. These are usually going to be measures. And so these are things like height, time, length, things like that that you can measure. Okay? And for discrete versus continuous, sometimes you might just have to identify, is that a discrete variable or a continuous variable? So remember, discrete is no decimals and it's counts. Continuous is when you have a decimal and it's something that's like a measurement. Okay, the big part that we're going to spend most of our chapter on is creating something called a probability model. Come here. Highlighter. I want to highlight. Yeah, okay, hold on, there we go. A probability model is a collection of all possible outcomes and the probability that they occur. So the variable, this is where you list the different options in words. You list it in words. Like, what are the different options in words? The result is usually what the value is. So if I get something, what's the value of it? And a lot of times it's going to be point values, dollar values. It's like shooting a basket. A 3-pointer's worth 3 points. A 2-pointer's worth 2 points. A free throw's worth 1 point. That's the result. The variables would be the different types of shots. And then the probability is what probability each of those events have. And so the way you find the expected, and this is the big thing that we're going to focus on, is the expected. The way you find the expected is you do result times probability equals the expected. This variance you're going to see in the table in the book and some other tables. This is how you kind of calculate the square root. We are not doing this by hand. We're going to let the calculator do all those calculations for us. Okay, so the expected, and that's kind of what I said here, the important thing is the theoretical long run average value, okay? So it's the mean of the probability model. So EX, that means expected, that's that symbol. So it's the mu. And so what we do, and I'm going to show you the formula, but once we do a problem, it's going to make a lot of sense. So it's the sum of the value, which is this value here in the table, times the probability of that value happening. And then you add them all up. So you do all the multiplications and we add them up. And so again, once we have an example, it'll make sense. For this one, eventually I'll show you how to find the answer in the calculator, right? But this, you have to show your work. So you must show work for this. And especially for the AP exam, they will not give you points if you don't show work. Okay? And again, a lot of this sounds a little strange, but once we do some examples, it'll make more sense. Okay, so the variance is just the square of the deviations. It's kind of part of the formula. Remember back a while ago, we calculated standard deviation by hand. Here's a formula that you're going to have. We're not going to really use this. We are going to find all of this stuff right here. We're going to find that using the calculator. So you will not have to calculate it by hand. Okay. We will find everything in our calculator. All right, so now let's go ahead and actually look at a problem so you kind of understand what happens. So again, let's look at this table right here. We have to list our options, then we're going to list our results, what their value is, then we're going to have the probability, and then we're going to find the expected. Okay, so a player has $55 and draws a card from a deck. A player pays you $55 and draws a card from a deck. If he draws an ace, you pay him $100. For any other ace, you pay him $10. For any other heart, you pay him $5. Everything else, he loses. Okay, so we're going to do this, and depending on the way, but because it says it pays you money, we're going to find out what's your profit. This is for your profit. Okay, so the first thing I do is I list my options. So right here, it says he gets an ace of hearts, and then we have a ace, another ace, any other ace. Then what else? For any other heart. And then there's also everything else. So everything else. Everything else. Okay, so remember what happens here. And again, this is the title. This is the value. And then we'll have the probability. Okay, so let's fill in the probabilities. I think that's actually the easier part right now. So an ace of hearts, there's one ace of hearts out of 52 cards. There's a total of 4 aces, but you've already used one, so there's 3 aces here. Other hearts, there's a total of 13 hearts, but we already clad the ace of hearts, so that means there's 12 other hearts. When you add up all those, 1 plus 3 plus 12 is 16, and so that means the probability of everything else is 52 minus 16 is 36 out of 52. You can change these into decimals, but you don't need to. I just keep them as fractions. And now what we have to do is we have to think about the value. And so you are getting paid $50, $55 for a game. The easiest place to start is down here. Everything else. These people lose their money. They don't get anything. So you're going to get a profit of $55 because they didn't win anything. Okay, so now a heart, you pay $5. Well, they originally gave you $55, but you're giving them 5. So your profit is only $5. You can show your math here, but you don't have to. I'm doing it just for notes so you understand what's happening. Aces are $10. And again, they paid you $55, but you gave them $10 back. So the profit's 50. And then for the next one, if they get the ace of hearts, you're losing money. This is the only time you're losing money. And so you're losing, what is it, 100 minus 55? You're losing $45 because I'm losing money. That's a negative. Okay? And so what I'm trying to find out is what's my expected profit? In the long run, how much money will I earn by having this game? Okay, so now we do our E of X. So we're going to do negative 45 times 1 over 52. We're going to use our calculator. Pull my calculator into this. That's so small. Hold on. Okay, so, turn on. So negative 45 times, oops, that's a 44. 45 times 1 divided by 52 gives me negative 0.865. So negative 0.865. Okay, now I do the next one. And so 45 times 3 divided by 52 is $2.59. So 2.596. So 2.596. Okay, now we're going to do the next one. You keep doing that. 50 times 12 divided by, 12 divided by 52. And so 11.538. And then the last one, 55 times 36 divided by 52. And that one is 38.077. Okay. And so what I did right here is I just showed my work on how I found all my expecteds. To find the actual answer, you add those numbers up. So let's see, I'm just going to do, where'd you go? It's annoying. So I'm going to go up because I don't want to have to type them all in again. So this one plus the 2.596, this one, plus 11.53, this one, plus, and it might be a little different because I didn't round, but essentially I've added all those, and so now I get 51.35 cents. That right there is my expected profit for each game. Now, when I write my summary for it, what this means is that every time someone plays the game, I want to type versus, I don't think I want to draw, I want to type. Maybe if it lets me type. Yeah, it's not gonna have to, I'm gonna have to draw. Sorry, guys. Sorry, that took a while. So, every time someone plays the game, every time the game is played, I can expect $51.35 in profit. Now, it's not always exactly that amount. Sometimes it's higher, sometimes it's lower. But when you do this over and over and over again, that is the amount of money you're going to get. So this game is extremely profitable. So if you're the one playing this game, the opposite is true. You can expect to lose $51 in the long run each time you play the game. So this would be a game I would never play. Okay, so that's the expected cost. What we need to figure out now is the standard deviation. And again, I said we're going to do this in the calculator. So what you have to do is in the calculator, you're going to type in your values in L1 and your probabilities in L2. So go ahead and do that real quick. So when I type in my fractions, it's going to turn it to a decimal right away. Oh, I don't need to do that. 1 divided by 1 divided by 52. It turns it into a decimal. So once you have it all in, and it's okay to have the, okay, so follow my steps together, and then I will write down the directions on your screen so you can write it down too. But what we're going to do is we're going to first hit stat. Now that we've got our data in, we hit stat, and we're running a 1 vars stats. We're doing a calculation of 1 vars. The difference here is that our list in L1 is in L1, but our frequency, which is our probability, is in L2. So you have to put the probability in L2. And then I calculate, and here's all my numbers. Something's wrong. Why did I get 51? Let me go look back. Maybe I made a mistake in my table. Hold on. Okay, I found a mistake. I had typed in 50 twice instead of 50 and 55. Okay, so now stat, calc, 1 vars. My list is in L1. My probability is in L2. I calculate, and look, we get the exact same value, 5134 or 35, 5135. This sigma x right here, that's the standard deviation. So your standard deviation is 1380. So we get a profit of $51.35 with a standard deviation of, what did I say it was? $13.80. Okay. It says, would you play the game? I would never play the game, but if I could get suckers to want to play the game and I'm the one running it, I'm going to earn a lot of money. But I would never spend my money on the game. And so using expected values, it kind of lets you figure out, is it worth it? Would you do something because you can see what your expected value is in the end? Okay, so when you do these problems, again, you have to set up a table and you have to show your work. You have to set up this. This is called a probability model right here. And so you list the different options, you determine their values, you find the probability, and then you multiply to find the expected value. Let's write these calculator steps I said I would, and I totally already forgot. I like this. We're going to use this Galaxy pen. This one makes me smile. So calculator steps. Okay, so you put your values in L1. You put your probabilities in L2. You go stat, and I'm going to put a box around it to tell you that that's the key. You go to calc, and you choose number 1. And from there, your list is L1, and your frequency is L2. And remember your mean, what was the mean? I think it does the X bar. Yeah, your mean is X bar. So your expected, which is the mean, is the X bar. And your standard deviation is the sigma x. Okay, so even though I can find my expected value in my calculator, you are always expected to show your work. And this right here is enough showing your work. You can do your table to show your work this way. But set up the table, make sure you list everything. A common mistake is people don't list things. The probabilities should add up to 100%.